Hello, today we're going to be talking about interfaces in Java. Note that this topic is not on the AP exam and that all the details for interfaces are updated to Java 8. So imagine you're a car owner with dozens of cars, with many types of brands, models, or functionalities. You want to organize them and simulate how each car functions or works using coding. You know that cars have shared behaviors of both methods and attributes. Some cars may have the same brand, some may be able to drift, some may have the same sound. So some examples of the behaviors of different cars can be the brand, model, price, and speed, which are all attributes, or the actions, which are driving, parking, refueling, maintenance. Groups of cars, for example electrical cars, have shared behaviors, like having an attribute of electrical efficiency. Also, its actions would be different, like having a method of charging rather than refueling for traditional fossil fuel cars. At the same time, sports cars might have special actions like drifting, which may not be present in other cars since not all cars can drift. Also, the cars of a brand like Mercedes-Benz might have special features, like having an automatic warranty, or being able to have maintenance specialized for Mercedes cars. Such groups of cars have common behaviors of attributes and actions. However, notice that some cars are within multiple groups of cars. For example, the Silver Arrow by Mercedes-Benz, as in this image, is both an electrical car and a sports car. Also note that there is no direct hierarchical relationship between the groups. An electrical car is not always a sports car, without an is a relationship between them. An electrical car is not always a Mercedes car. If you learned about inheritance, a class can only inherit from one superclass. So how can the Silver Arrow have the shared behaviors of all three groups? By merging the behaviors of all electrical Mercedes and sports cars, of their attributes and actions, and passing it on to the Silver Arrow, we can know what behavior it has. From previous examples, any objects that are silver arrows should have fuel efficiency, warranty, and their attributes, as well as actions of charging and drifting. So how would this apply to programming? We can use interfaces to tackle this problem. In Java, each type of car, for example electrical cars, can be represented by an interface. Interfaces are basically templates for a class that the class can implement. Interfaces have behaviors like methods and attributes, like a class. If a class implements an interface, the class will provide a functionality specified in the interface. In this example, in Java, we can represent each type of car, for example electrical cars, with an interface. An interface is a template for a class that a class can implement. Interfaces, like classes, have behaviors, including methods or attributes. If a class implements an interface, the class will provide a functionality specified in the interface. However, interfaces are in many ways different from classes. For example, everything in an interface is public, since they must be accessible for other classes and cannot be on their own. Even if it's not specified, it is public, so the public modifier is optional, as in here of how these two, and these two are basically the same thing. Though private methods and interfaces are possible in Java 9, they will not be discussed as this PowerPoint is only about Java 8. There are also many special aspects of interfaces about their methods, attributes, and how they're used. They will be discussed later on. So how to use an interface? Well, first, to declare an interface, we first use the interface keyword followed by its name. The public modifier is optional, but using it provides clarity for the code. In order to implement an interface for a class, so the class will provide the functionalities of the interface, we need to use the implement keyword. In this example, the class child car implements the interface of parent car. One special aspect of interfaces is how a class can implement multiple of the interfaces, which is separated by a comma here. The concepts behind why this is possible will be explained later. One interface can also obtain the behaviors from other interfaces by extending it from it. Interfaces can extend from multiple interfaces, and we can use the extends keyword in this case. For example, for the new parent interface, It can extend multiple other interfaces using the extend keyword and also using a comma to separate the names of each interface. To begin with, there are three types of methods in interfaces: abstract methods, which are always instance methods; default methods, which are also instance and static methods. Abstract methods in interfaces are not implemented, which means that they do not have any method body. They only have its method header, which consists of the method's modifiers, return type, method name, and parameter list. If there is no specific keywords, specifically static or default, mentioned in the method header, then the methods in interfaces are always public and abstract. They are abstract as they lack a method body and are incomplete, so they need to be overridden. They are instance methods, which means they need to refer to an instance object when called. Once implemented, the class is promised to implement all these abstract methods declared in the interface by overriding them and creating instance methods of the same method signature, return type, and accessibility in the class. Both of these methods are public and abstract, even though there is no modifiers explicitly saying they do. In the class that implements the interface, it must override these two methods by implementing them and completing the method body. If a class implements two interfaces with methods of the same method signatures, which means they have the same name and parameter list, if they have the same return type, the methods of the interfaces can merge as one and is created in the class. However, if they have different return types, the methods cannot merge together. So when the method is called using its signature, Java will not know which method to run, causing a problem. For example, when these two interfaces are called, because of how these two methods are different from each other, then they both need to be implemented separately. When new method is called, Java will not know which of the two methods to call, therefore creating ambiguity and causing an error. What if you do not implement all the abstract methods required by an interface? Well, this would mean that the class does not fulfill its requirements as not complete, causing a problem. To resolve this problem, the class must be declared as abstract, meaning it cannot create objects since it's incomplete. Being an abstract class would force its subclass to implement the leftover incomplete methods to fulfill the interface, so only if the subclasses complete the implementation can they create an object. Because of how new method is incomplete and not overridden yet, the child card class is incomplete, so it would force its subclasses to implement the leftover incomplete method of new method, as in here. In Java 8, interfaces have default instance methods that are already implemented in the interface, which means that they have a completed method body. Creating a default method requires a default keyword followed by the return type method name and parameters. These default methods, unlike abstract methods, do not need to be implemented in the class. However, the class can override these default methods if they wish to. This allows for classes being able to call the methods from the interface like inheritance. For example, in this scenario here, the child card does not need to implement the new method. Rather, it can simply just call it from the interface. Unlike the previous two, static methods do not need to refer to an instance object. Like default methods, static methods must be completed within the interface. However, the class cannot override or replace a static method in the interface. The class can create a static method of the same method signature though. To prevent ambiguity, all static methods in the interfaces must be called using the dot operator to refer which interface that the static method is from, based on the interface's name. For example, we have a new static method called new method. In order to access new method in the child card class, we need to use a dot operator that references the static method's interface name, parent car, as here. All variables in interfaces are public, static, and final, even if these keywords are not mentioned. Static means same for the entire class. Variables must be static because interfaces cannot be instantiated on their own and there are no objects. Final ensures that the value assigned is constant and cannot be reassigned. All variables must be initialized when they're declared inside the interface, otherwise causing a compilation error. Two interfaces with variables with the same name would cause the variable to be ambiguous when the variable is called. This is resolvable by using a dot operator to specify which interface should the variable be from. Thank you for watching.